Okay, now we discuss the problem related to thermodynamic process. This PV graph shows the combination of many thermodynamic processes. There are 5 processes according to the number of arrow. Process AB, process A, B to C, process A to C, process A to D, process D to C. When the gas expands from state A directly to C, the total quantity of heat absorbed by the gas is 10 kilojoule absorbed by the gas. So QAC is equals to positive 10 kilojoule. Determine A, the change in the internal energy of the gas delta U A to C. B, the total quantity of heat transferred to the gas if the following paths of the process are taken. 1. Path A, B, C. 2. Path A, D, C. Solution A. To find the change in internal energy delta U A to C, first we have to calculate the work done A to C. The work done A to C is equals to the area under the trapezium below line AC. We go to the graph. So we have to calculate the area under the graph A to C, this trapezium area, is equal to 1 over 2 times in bracket 3 times 10 power negative 2 minus 1 times 10 power negative 2 times in bracket 8 atm plus 2 atm. We have to convert atm to the SI unit Pascal, which is 1 atm is equals to 1.01 times 10 power 5 Pascal. So we got the work done AC in SI unit joule, positive 1.01 times power of 4 joule. Now we go to the first law of thermodynamics. Q is equals to delta U plus W. So QAC is equals to delta U AC and W also A to C. So delta U A C is equals to QAC minus WA to C. QAC mentioned in the question is equals to positive 10 kilojoule. So we substitute delta U A to C is equals to negative 0.1 kilojoule. Internal energy decreases when the gas expands. T final, T at C, is less than T initial, T at A. So decreasing in temperature, we get the answer is negative sign for delta UAC. Question B. The total quantity of heat Q. So we have to calculate Q A B C and Q A D C. The first step, we have to calculate the work done. To calculate QABC, we have to calculate the work done ABC, which is equal to the area of rectangle below line ABC. Rectangle, line ABC. So this area is equal to 8 times 1.01 times 10 power 5 times 3 times 10 power negative 2 minus 1 times 10 power negative 2. 8 is ATM. We have to convert to Pascal times 1.01 times 10 power 5. So we get QABC is equals to 16.1 kilojoule. The change in internal energy delta U is independent of the path taken. It is depend on the final temperature and initial temperature. So delta U A to C is equal to delta U ABC also is equal to delta U in change in internal energy ADC is equals to negative 0.1 kilojoule. So by apply the first law of thermodynamic process, QABC is equals to delta UABC plus WABC is equal to negative 0.1 kilojoule plus 16.1 kilojoule. So we got QABC is equals to 16.0 kilojoule. Question C. To calculate QADC, so the first step we have to calculate the work done ADC, which is area under the rectangle below line DC. If we refer to the PV graph, work ADC is area under the graph DC, this area. So area of rectangular below line DC is equal to 2 times 1.01 times 10 power of 5 times 3 minus 1 times 10 negative 2. So we got 4 kilojoule. Then apply the first law of thermodynamic process. QADC is equals to delta UADC plus work ADC. Negative 0.1 kilojoule plus 4.0 kilojoule. We got the heat energy for path ADC is equals to 3.9 kilojoule. Okay, example 4. Look at this PV graph. Pressure in unit kilopascal. Kilo is times 10 negative 3. And volumes in unit cubic meter. So we got 4 process, 4 arrow. Process A to B, process B to C, process C to D, and process D to A. A vessel contains an ideal gas in condition A, as shown in the figure 14.3. When the condition of the gas change from A to B, the gas system absorbs a heat of 2.55 kilojoule. So 2.55 kilojoule is absorb. Absorb is positive sign for Q. So QAB is positive 2.55 kilojoule. When the gas in condition B changes to C, there is a heat transfer 5.32 kilojoules. So QBC is equals to 5.32 kilojoule. Calculate A, the work done in the process ABC. So if we refer to the PV graph, work done ABC. Work done is the area under the graph. A to B, B to C. So two process. So work done ABC is equals to work done process AB plus work done process BC. Work done for process AB is equal to 0, because if we refer to the graph, PV graph A to B, there is no area under the graph. So work done A to B is equals to 0. Work done plus work done BC. Work done BC is the area under the graph. This area for BC. So this area, so is equals to 150 times 10 power negative power 3 for pressure, times in bracket 3 times 10 power negative 2 minus 2 times 10 power negative 2. So we got work done ABC is equals to 1500 joule. Question B, the change in internal energy in the process ABC. So delta U ABC. By applying the first law of thermodynamics, the heat for process AB to C ABC QABC is equals to delta U ABC plus work done ABC. QABC, okay, delta U ABC is equals to QAB. QABC is equals to QAB plus QBC minus work ABC. Given in the questions, QAB is equals to 2.55. We convert to the SI unit, kilo. So 2.55 times 10 power 3 plus QBC 5.32, convert to the SI unit, times 10 power of 3 minus 1500 joule. So we got internal energy delta U ABC is equals to 6370 joule. Now we go to question C. The work done in the process CDA. The work done in the process CDA is W CDA. We refer to the graph CDA. From C to D, D to A. So work done is the area under the graph. Area under the graph CD, same with A to B. There is no area under the graph because volume is constant, isovolumetric or isochoric. So work done W C to D is equal to 0. Work CDA is equals to work CD plus work DA. So we have to calculate work DA, area under the graph, this area. Okay. So work CDA is equals to work CD plus work DA. Work CD is equal to 0 because constant volume, there is no area under the graph. So work CDA is equal to pressure at D times delta V, the change in volume, V final, VA minus V initial, V at D. So substitutes pressure at D 100 times 10 power 3 times 2 times power negative 2 minus 3 times power negative 2. We got work done CDA is negative value, negative 1000 joule. Okay. Question D. Question D. The total amount of heat transfer in the process CDA. Q CDA. So we have to refer to the first law by applying the first law of thermodynamic process for CDA. So Q CDA is equals to delta U CDA plus W CDA. Delta U CDA is negative value. Delta U ABC is positive because temperature is increases. Temperature increases. T at C, T at A, which is T at C is greater than T at A. So delta U CDA, okay, T at C, T at A. Delta U is depend on the final and initial temperature. The magnitude of delta U same, but the sign is different. Delta U CDA is negative because decreases in temperature. Final temperature T at A is less than initial temperature T at C. So negative value, which is equals to delta U CDA is equals to negative delta U ABC. So by substitute Q CDA is equals to delta U negative delta U ABC negative 6370 plus work done CDA plus minus 1000. We got heat energy process CDA is equals to negative 7370 joule. Okay, thank you.